Hello everyone. In this video, I will present my microcontroller-based gas monitoring and alarm system, developed using the NXP KL25Z microcontroller and several external hardware components. I will start by briefly introducing the hardware components, then explain how the system works, and finally focus on the interrupt mechanism used in the project. The main sensing component of the system is the MK4 gas sensor, which detects combustible gases and produces an analog voltage output proportional to the gas concentration in the environment. This analog signal is connected to ADC input of the microcontroller. For user feedback, a 16 to 2 character LCD display is used. The LCD shows the current gas concentration in ppm, as well as the system status such as safe mode, warning levels, or alarm condition. To improve LCD visibility, a potentiometer is used to adjust the LCD contrast and brightness. By manually changing the potentiometer value, the user can optimize the display for different lighting conditions. This demonstrates the integration of analog components for real-time user control. The system also includes 3 LEDs, each representing a different gas concentration level. These LEDs provide a quick visual indication of current safety status. For audible alerts, a buzzer is used. The buzzer is driven using PWM output, allowing controlled activation during alarm conditions. Finally, a push button is included to mute the alarm when needed. This button is implemented using an interrupt-based approach, which I will explain shortly. The gas concentration thresholds used in this project were not chosen arbitrarily. They are inspired by general safety and exposure guidelines published by international health and environmental organizations, such as the World Health Organization and similar safety authorities. Based on these references, the system defines 3 gas levels: a safe level, where no immediate risk is present; a warning level, indicating elevated gas concentration; a critical level, where immediate alerting is required. By grounding the thresholds in real-world safety guidelines, the system reflects practical gas monitoring behavior rather than purely theoretical values. The MK4 sensor output is continuously read using the ADC module of the KL25Z. The raw ADC value is converted into voltage and then mapped to an estimated ppm value in software. This ppm value is compared against the predefined thresholds. Depending on the result, the corresponding LED is activated. The LCD display is updated, and if the critical level is reached, the buzzer alarm is triggered. A key feature of this project is the use of a GPIO interrupt for the mute button. The button is connected to a pin PTA4 and configured to trigger an interrupt on the following edge. When the button is pressed, the microcontroller immediately executes the porta interrupt handler independent of the main loop. Inside the interrupt routine, the alarm mute state is toggled, a software debounce mechanism is applied, a flag is set to notify the main loop. Using an interrupt here ensures fast and reliable user response, even while the system is continuously reading sensor data and updating the display. The system also uses the SysTick timer interrupt to generate a millisecond time base. This timer is used for debouncing, buzzer timing, and non-blocking delays, allowing the system to remain responsive at all times. The use of safety-based gas thresholds, a potentiometer-controlled LCD, and an interrupt-driven mute button improves both usability and system reliability. Thank you for watching.